So generative shape design has a bunch of different toolbars, from wireframe to surface toolbar to operation toolbar. This other volumes toolbar we don't really use too much, so actually I need to fix this. This is volumes toolbar. I mentioned something about it, but we don't use it. And then BIW toolbar also. It's quite more advanced. I'll show you, but we don't use too much. The toolbars that we use frequently are operation toolbar, wireframe toolbar, and surfaces toolbar. So there are so many commands in it. And here I would like to show you some of these commands first through this example, this practice example together, and then I'll show you the rest as we go forward. But one way to create objects with small thickness, thin objects like sheet metals, is that we create their surface first and then convert those surfaces into solid objects. So what's the difference? A surface is a 2D object that has no thickness and no mass, okay? It's really something imaginary, okay? It does not exist in real life, but we use them as the boundaries of the objects, and they help a lot, as I show you later. When we want to create solid objects, we can start by creating the surfaces. And again, the reason is CATIA has so much flexibility and so many tools when it comes to forming surfaces that it does not even have when you want to create solid parts. So we can always create surfaces, then convert them into solid objects, and I'll show you. So here we have this L-shape component, which has two holes, an elliptic one and then another kind of rectangular one. And the thickness is given, all the dimensions are given, and we are going to create this. So as you can see, if we want to start, we start with the L-shaped profile and then extrude it to get the first part done. And the dimensions for it is 2 units height and then 1.75 width. Okay, so here we go. And in order to do surface design, where we need to go is we go to Start, Shape, then we go to Generative Shape Design, give it a name, and choose a plane, let's say YZ plane, click on the sketch, and then we use the profile command, and we draw a profile, make sure our units are in inches if we haven't changed them. So tools, options, then parameters and measurements, units, and you see they are on inches, so we are good. Double click on this and then provide the dimensions. So this guy was 1.75 and this one was 2 units. There we go. We also have a fillet radius of 0.5 at the corner. So let's do that. There we go. Now we exit. And now, just like rigid bodies, where we had a closed profile and we could extrude it into a solid object, here we can extrude a sketch into a surface. The difference is here your sketch does not need to be closed. You can extrude an open sketch and convert it into a surface. And the surface command here is under the surfaces toolbar. That's the very top one. So you choose that and then you extrude 3 units, which is the depth of the part, right? So say I want 3 units, and you see it has the same features that you had for extrude, right? So you have direction 1, direction 2, mirror, extend, reverse direction, and so on. And so here we go. That's a surface. Another thing you probably notice is color. So remember, in CATIA, default color for parts is what? Gray, light gray, while for surfaces is yellow. Okay, so that's another way to distinguish between a surface and a part using color. Okay, now here on this back wall, we have a 1 by 1 by 1 and a radius of 0.25 that we need to hollow out. So here we click on this back surface, we go to sketch, and we draw our rectangle like that. Make sure the bottom edge is coincident with the bottom edge of the part. Then we provide the dimensions. So this guy is 1 unit, the height is 1 unit, and the gap between one edge to the side is also 1 unit. There we go. And then we have fillet radius of 0.25 on these two corners. And on the other one. There we go. And we get out. Now, in surfaces, we don't have a cut extrude command, okay? Because there is no solid thing, so we cannot really cut extrude. As you can see here, we have the command for offset, we have for sweep, we have for fill, we have for loft, blend, and so on and so forth, but there is no cut extrude command. The only way that you can do it, if your surface is entirely, if the curve is entirely on the surface, then under the other toolbar for operations, the top command is join. The second command here is called what? Split. And then there are two commands here that we're gonna talk about. One is split, the other one is trim. So here we choose the split, and it says, okay, what is the element you want to cut? I say this guy here, and says, what is your cutting element? And I choose the sketch. And the part that is going basically very bright, very low color, right? It's kind of opaque. That is the part that is going to be eliminated. So this part is going to go away. If you want the rest of it to be eliminated, you click on the other side, okay, to keep this. So you can say remove or replace. So no, actually I want this to be removed. So there we go. Right, so now that is gone. And if you don't want these sketches anymore, you can just hide them. Okay, don't delete anything, just hide. So right now we got this guy very well. And then we need this elliptic hole, which is 1.125 semi-major and 0.56 semi-minor at 1 unit from the left edge, and it is centered. So what we need to do is click on this top face, go and draw the ellipse like that. Then this guy from here to here is 1 unit. Then the major diameter, as you can see, is 1 times 1 so is 2.25. And then semi-minor, we click on it again, but you see when you click on the ellipse again, it's not going to give you semi-minor, it's still again going to give you semi-major unless you right click here and say no, I want semi-minor axis. And this guy is 1.125, right, which is twice as big as, or yeah, 0.56, right? So you're going to get, no, actually you're going to get 1.12. So this is 1.12, not 25. Okay, and then you need to make sure also this guy from the side is 1.5. There we go. So that is your ellipse. Now, the problem is if I want to use this ellipse again and do the similar thing, use a split and cut the hole out, the problem is this ellipse is not completely on the surface, right? You can see that because the ellipse is big, this ellipse is not completely on the surface, and if you try to cut something with a sketch that is not completely on it, it is not going to like it. It is going to give you error. Let's just try it. So the element is this guy, and the cutting element is this one. Look, it says, hey, it's not completely on the part. Okay, I cannot split. I have some separation of curve from here to here, so it is not going to do it. So what should you do in that case? You should project that ellipse onto the surface first, and then use that projection for cutting. And you might say, how do I project? Well, you go to the wireframe toolbar, and if you look at the wireframe, this very first command after the plane says projection. So you choose this sketch and you say, I want to project this. It says on which surface? You say on this guy, and you okay that. And now if you hide the original sketch, look, you got this ellipse, which is the projected version, and it is really, it's not a flat ellipse anymore, but it is completely on the surface. So now I can use this guy if I want to cut it. So now I say, okay, now I want to cut this guy with this projected ellipse, and there we go. Right? So make sure that your splitting element is on the splitted surface or support. There we go. So now I got my geometry, and now I have to provide it a typical thickness of 0.05, right? And then later I can provide this 2 radii of 0.5 fillets, because there is one fillet here, one fillet here. Okay, so I can give it thickness now and then apply fillets. So one way is this. I have my surface. Now how do I convert my surface into a solid object? So we go under Start, Mechanical Design, and go to Part Design. And now use this tool that we haven't used so far in Part Design. It's called Thickness. So that's this guy here. If you click on that, it says, what is your surface? Say this guy. This is what is your thickness? I say 0.05. Then you can define the direction of thickness. Do you want it to be outside the surface or inside? Which, based on this figure that I have, since 1.75 is given until here, the thickness is outside. Okay, so I go there. If you want to change directions, you can. Okay, so you can just click on these arrows, and there we go. Now I got my solid object, and this surface now I can just hide it. So now I got my part done. If I want, I can apply material to it, right? So let's say make it a sheet metal out of aluminum, and I can also render it with material. There we go. So now you got yourself an aluminum sheet metal. Okay. Now if you want to do those fillets, which were 0.5 each, so you use your fillet tool as we did in the past, and choose this edge, say 0.5, and also at the same time, if it allows you, you choose this edge. There we go. Right? So now you got yourself the final product. So we can do it this way. So we'll learn now how to create a basic surface, how to use this thick surface command to convert it into a solid object with giving it some thickness. And we have done our first example. Okay, so I guess I have gone through extrude, projection, split, and so on. Now here is the part that I need to talk about this tool here, let me show you that. So you see, this is how I converted my part into a solid object, right? Now, let me get rid of the material and the edge, the fillet edge, and the thickness, and just bring back the surface I made. Okay, so now if I go back to generative shape design, there is a toolbar here that is on the right side. Now here I have closed it, but if you want I can bring it back. It's for volumes. Let's see if I can find it. There we go. That's this guy. This toolbar has a command very similar to the thick surface command we use in part design. This also guy called thick surface. And we can use this one and apply it to this and create something that looks like a solid object again, right? Look, it looks like a solid part again. And it has thickness and everything. Now, what's the difference between this one and this other one, right? So first thing that would be quite obvious to you is the color. The one we made with the thick surface in part design was gray, which is the default color for parts. This one is not. It's kind of maroon, right, or purplish. So this color, when you see that color, it's not a solid mass object. It is called a volume object. Okay, so what's the difference between this one and that one? For example, one of the differences, although I mention it in the next slide, but one of the major thing between this one and the next one is if you take the previous one to structural analysis here and apply some load on it and want to measure the stress, strain, and so on, you can do it with the one that was gray, right, with the one that you create in part design, but you cannot use on this guy. You cannot apply material to this, and you cannot really, this one does not really have too much mass properties and moments of inertia. So you cannot take this one to structural analysis. It does not, it's not going to allow you to do structural analysis on this volume. It has to be the gray part with the mass. But what is really the difference between them? So the difference is this, between volumes and solid, okay? So there are two major ways that we can show parts. One of them is called CSG, or constructive solid geometry. That's one way to show objects. The other way that is used also in CAD software for showing objects is called BREP, or boundary representation. So what's the difference? So let's say if I want to show you a cube, right? How do I show you a cube? One way is you really have what? You have basically some extrude, or you can use some Boolean operations or something, and you have really a solid mass, right? So it's a parametric design. And how would you define this object? You say there is a cross section and there is some extrude to create this object. Now, another way to show it instead of this fully solid object is I really only show the object by the boundary surfaces. Okay? So it's like the object is kind of hollow, and all I'm showing is the surface of the object. Okay, so it's a bunch of boundary surfaces that I connect together, and those show what? The part for me. So inside the part is hollow, and that's why I said you cannot do stress analysis on it, right? So this guy here is not really a solid pipe. It's just a cylindrical surface here and a circular here and here. Inside it is hollow. So this volume command is showing volumes, but not by filling them out, just by showing the boundary surfaces. While what we did in part design, it is really a solid object. So since this toolbar using the brep method for creating volumes, it is not suitable for many applications. Now, why then we have that if it's not useful for many applications like a structural analysis? Why do we have that? Well, solid models, they use more memory, okay? Because you need more info to save inside the memory of CATIA or computer to represent this part. Here, it's just a bunch of surfaces. And so when you work with volume objects, if all you want is to show how the part would look like, you don't want to do further analysis on it, these guys are faster to work with. They are easier. They take smaller volumes compared to a solid model. Okay, so if you have memory or graphic card limitations or RAM limitations, and again, you don't want to do structure analysis, you don't want to 3D print your parts, convert them to a mesh or something, you might just want to go with volumes instead of solid objects. But for our computers, I really do not recommend you use this toolbar at all. Now, you can do a bunch of more things in here to do revolve, to do sweep, to do multi-section. So all of those commands that we had in solid objects, we have here too. We can revolve, you can sweep, and you can do multi-section. And I'm gonna show you. You can do patterns, you can do mirror, you can do scale, affinity transform, you can do surface measurement. There are new commands like intersection, extrapolation, bump, filling surface, which is one of the ones that is used a lot, joining surfaces, and then what? Fillet and chamfer. So you can do fillet and chamfer too here, right? And then you can do surface offset, create a hole on a surface, blend surfaces, trim surfaces, split, which I showed you, but you can split 3D parts using surfaces, and there are so many more. Okay, you can create 3D circles and splines. We did the helix in the past, the spiral. You can create laws and then create curves from the laws. What is geometric set? Parallel curve, creating a local coordinate frame, and then freestyle and sketch tracer. So there are a ton of info that I have to cover in this lecture. Therefore, let's get started. So as I said, one of it is revolve, sweep, and multi-section. So let me show you very fast a sample for each one of them. So we go back here. So as I said, you can draw any surface that you want. Let's say you want a what? You want a spherical surface, right? Like a ball. So if you go to any of these planes, and all you need to do is to draw a semicircle. So here I draw a semicircle for you with the line and then the 3-point arc, like that. Then I get out, and then you use the revolve command here, which is under extrude. So if you expand extrude, then you have also the revolve command. By the way, you can directly create a sphere or cylinder if you want to, but just for the moment I use this guy. For axis of revolution I use this. Then I can provide the amount of rotation I want. Do I want full revolution? Do I want 180 or so on and so forth? Right, so I can provide the angle, and there we go, right? So I could get myself a spherical surface, and then if you want, I can show you later how to convert that into a solid part. Okay, so this is about revolve command. As I said, we have the sweep command and we have the multi-section. So let me show you those. So for the sweep command, let's draw a profile. And we can provide some fillets here. Like that. Then we use the plane command, make it perpendicular to that at this point. Then go on this new plane, draw the cross section. And get out. And so now I can click on the sweep command, say sweep this one with this surface. And there are too many controls here that you can check. Okay, so if I want to create a pipe, I can basically do a sweep command. Now, one command that is useful is sometimes you don't want to create a pipe. What you really want is a pipe with the caps. So you want the two ends to be closed, not open like this. That's where you use the fill command. And fill command is a command, if you provide the boundary of the surface, it fills it with a surface for you. So I say I want two caps, one here and one at the other end. So I click on fill. It says, okay, what is your boundary curve? And I say, this is my boundary curve, fill it for me. There we go, right? So now this guy is filled. And now I can repeat that with the other one. So I click this one and then I click that, and as long as it's a closed boundary, I can get myself the closed pipe. Now the thing is, let's say if I want to give this closed pipe some thickness, right? You want to use that thick command. The problem is you have here three separate surfaces. One is sweep, one is fill, and the other is this fill. And you cannot go and apply the thickness individually to each one of these. When you apply thickness, whether it's volume or solid object, you can only apply to one single surface. You cannot do it to each one of these three guys individually. Or if you do it to one, then you cannot do it to the others. So how can I combine all of these three surfaces into one single surface, which is the surface of the entire part, and then basically apply thickness to it? Or let's say somebody says, what is the total surface area of this pipe? So if you want to measure it, instead of measuring each one of these separately, what I can do, I use this top command here under operation called join. And I say I want to join sweep to fill 1 and to fill 2, and as long as they have connection and tangency, there we go. Now instead of these guys individually, I have what? Join 1, which is the entire surface. And as always, you can go ahead and change this name, so I can call this closed pipe, right? So now this closed pipe is the entire surface. I can do measurements on it if I want to. So I can click on this guy and click on the closed pipe, right? And you see it gives me what? The entire surface area for this guy. Yeah. Now if I want to apply thickness to it, so I'll take it to mechanical design, part design, and then use this thick command, select the join, and then I give it either a thickness inside or a thickness outside. Let's say 0.02 inches outside, or if I want, I can make it inside. And there we go. Now it's my solid object. And you might say, where is the solid object? This is just the yellow surface. Yes, it is, but the part is inside it. Remember, we applied the thickness inside. So if I hide this surface now, there we go. I can see my solid part here. Of course, it has some limited thickness, so inside it, it is hollow, right? Correct? So you see clearly your walls have a thickness of 0.02. You can make them thicker, right? You can make them 0.1 to see better. So here we have now this pipe. Now someone might ask this question, hey, what if I want to convert that surface into a fully solid object? I do not want a hollow pipe. I don't want to give it a specific amount of wall thickness. I want to make it completely solid. How can I do that using the surface that you made, using this joint? Can I do that? And the problem is, if you look at the thick option, so here you choose the surface, you can give it some thickness. Now if you click on more, okay, do you see any option that allows you to provide full thickness and make it completely solid? At least I don't see. So what is your option here? So how can you convert this guy? Let me delete this. How can you convert this surface into something completely solid? So the way to do it is this. So you go ahead and you create a solid cube or anything that completely contains your surface. So here I create something like this, which can completely contain my part, and give it some thickness like that, right? So my part is now completely what? My surface is completely inside this cube. And now I use that surface to cut this cube into two parts. One that is outside the surface, one that is inside the surface. So I split the solid object with a surface, and then I can keep any of them that I want. Where, if you go here under this thick surface, then you can use the first command called split. And it says, what is your splitting element? I say this surface. And now it says, okay, do you want to keep the outside of the surface in the cube, or do you want to keep inside of the surface of the cube? I say I want inside of it. And you okay that? And there we go. If you hide this now you got your solid pipe. So if you look at this one, this is completely solid, okay? You don't see any wall thickness here. And if you don't like it or don't accept it, use dynamic sectioning and cut it and see it for yourself, right? So you can clearly see here that when you look at it, you have what? Full, you have filled cross section, right? It's completely solid. There we go. So one way to do it is to use the split command here in the part design. There is another way to do it, and that is using this closed surface. So let me show you that one. So this guy, you do not really need to create a separate cube like this to contain the part and then split it. So you have the surface only, and then you here go under close surface, you click on close surface. It says, hey, do you want me to close this? I say, sure, do it. There we go. And now if I hide this for you, there we go. I got my solid parts again, right? So this is very good. It's very fast. It doesn't need a separate part, as I said, to be splitted. But the split command has its own application, right? So here, for the split, you do not necessarily need your surface to be closed surface. Here, you have a closed surface, and then you filled it with solid part. So this command closed surface works mostly when this join that you use is a closed surface. But with the split command, you can split a part using an open surface, right? For example, let's say you want to trim something, or cut some cube or object with something, let's say if I go to mechanical design, part design, right, and I create, let's say, a sphere, the same thing that we did, but here we do a solid sphere. And now let's say I want to trim this sphere with a surface and create actually only a portion of it. So what I do is I go to shape, generative shape design, I go onto the surface, and then I draw an arbitrary shape here, something like an S-spline. Get out, extrude this guy. Now, when you split an object with the surface, the important thing is you need to make sure the surface completely cuts the object into two separate or disjoint parts. If it's partially cutting it like this, it's not going to work, right? So it's cutting it from the top and the bottom, but not from the left and right or front and back. You have to completely split the object into two parts. Here it doesn't do it. So here you have to make sure this guy is big enough, right? So I go like 4 units here and 4 units there. Now this guy completely splits the sphere into 2 sections, right? And so I can use it now. How? As I told you, you go back to mechanical design, part design, then click on the split and say this is my splitting element, and now it gives you the option. Do you want to keep this side or the other side? Let's say I want the other side, so say I want to keep this side, and I okay that, and there we go, and just hide the surface. Look, right? I have the complicated shape. So this split command is actually very powerful. So I showed you how to use thick surface, how to use closed surface, and how to use the split command in conjunction with creating a surface. Okay.